right, so we are now on to section 2.2. So we're going to talk about functions. So we kind of brought up a little bit about functions. We were talking about equations and functions, but we didn't go through a precise definition of really what a function is. So we're going to start with determining whether a correspondence is a function. And then from there, moving on to describing equations to a function about inputs and outputs, going back to graphing, um, and then something called a vertical line test, and then a few application problems if we can. So we're gonna have a lot of terminology. So this is where we're gonna hit a little bit of death by PowerPoint. So a relation, it'll be math anyway, is a correspondence between a first set that we call a domain and a second set that we call the range, such that each member of the domain corresponds to at least one member of the range. And that means that if you have an equation, if I put a number into it, that all those numbers I put in is your domain. Everything that comes back out is your range. So anything you put in the domain should at least come out to a number in the range. Basically saying I shouldn't have extra numbers in my range that I'm not using. So a function is a correspondence. It's a relation again, but it's a special kind of relation. Okay, so let me write that in there. Sorry. So a function it's a relation. And not that a special kind of relation. So it may be a little hard to recognize the difference between just a relation and a function because usually you are given relations that are functions, but sometimes they're not. So a function is a correspondence between the first set called the domain and the second set called the range, such that each member of the domain corresponds to exactly one member of the range. So what we mean by that, if I just have any old relation, we're going to call this my domain. So this is everything I put in, and this is my range, which is everything that pops back out. Let's put 3, 4, 5 there, and 10, 11, 12 here. So all a relation requires is that everything maps to at least one number. It can map to 2. It can map to 3. Like one number can map to everything, or every number can map to every other number. But what we mean by relation is that one number is going to go to at least one number and one other number. When you talk about when you talk about a function, let's write that down here. Let's say we have those same numbers again. What's important is that where this 5 here, this 5 went to everybody, right? So I said here is like, all right, this 5 could go here, this 5 could go here, this 5 could go here. Well, if we were talking about a function, that 5 should only be going to one number. This 3 should be going to only one number. This 4 should only go to one number. So anything in the domain should only have a mapping or correspondence to only one number that's in our range. I put that in there. So a function is a special kind of correspondence between two sets. The first set is called the domain. The second set is called the range. For each member of the domain, there is exactly one member of the range to which it corresponds. The kind of correspondence is, this kind of correspondence is called a function. So we're just saying one-to-one, not necessarily one-to-one, but it should definitely one number just go to that one other number. I'll have to cut that off just a little bit there at the top. Doesn't like to fit. There we go. Note that the bubbles in the domain and the right bubbles are in the range. Or sorry, left bubbles are the domain and right bubbles are the range. So usually when we talk about domain and range, domain is usually what comes first. So left, right, up, down. Domain is almost always first. And range is almost always what comes second. And our arrow is going to be our mapping, or what we've been calling correspondence. So I have a tendency to use mapping because that's what when I learned all this, that's what we called it. So these are types of functions. You have a one-to-one function, meaning one number goes to only one number in the domain, goes to only one number in the range. You can have one-to-many, where this one goes to one, this one goes to one. These two go to the same one. But what's important is that this 3 only goes to 5, this 4 only goes to 5. So as long as the arrow only goes to one number, that is fine. So 2 things in the domain can go to the same number in the range, that is fine. This is when it is not fine. This is when you get things that are not functions. So we have a one-to-many. So this 4 here, this is causing me trouble because that 4 is going to 2 numbers in the range. So 1 number in the domain is going to 2 in the range. That is not okay. Same thing here. This is okay. I can have 2 numbers go to the same number. This here, this is bad, very bad. This makes it not a function. If that happens, 1 number going to 2 numbers. So since each element in the domain maps to only one element in the range, these are functions. So they only go to 1. In the relationship to the left, the element 4, we see goes to multiple numbers, which is a problem, makes it not a function. We see the similar scenario over here with that 3. It also goes to 2 different numbers, making it not a function. Just a couple examples here. We want to determine whether this correspondence is a function. So this 8, it's only going to one number, so that's okay. Let's mark on the side. The 8 is okay, it's only going to one number. This 0, only going to one number, that's okay. This -5, going to only one number in the range, that's okay. All these only go to one number in the domain. These are all functions, sorry, only one number in the range. These are all functions. This is another one. Determine if this corresponds as a function. So functions don't always have to be numbers. So we got Jackson, Max, and Cade, and they can either play football, be in football, wrestling, or soccer. So Cade's only doing soccer. Cade's okay. Max, he's only doing soccer. That's okay. Jackson's the problem. Jackson decided he is going to do football and wrestling. Jackson is doing 2 things. This makes this not a function. And once again, remember, domain is always first, left to right, domain, range. So this is a good example because what we're looking for is that these people can only be involved in one sport. If you're involved in 2 sports, you automatically make this no longer a function. So if we look at these ones here, we have a domain, a correspondence, and a range. So we need to determine whether the correspondence is a function. So my domain is a set of rectangles. Just different kinds of rectangles. And then what we're doing is just in each rectangle's area. So if you want to, just write some out, try to think about it a little bit and determine when it does this and it goes to an area, is the correspondence between a domain of rectangles in a range of a set of numbers, which is going to be my areas, is that a function? So that is the kind of question you're being asked here. This is just to think about this a little bit. The 9 is we have a domain of singers that corresponds to the song that the singer has recorded and the set of song titles. So our singers, their domain, and then the range is their songs. Is that a function? And then this one, fill in the domain, range, and correspondence. So so the relationship between a father and his children is considered a function. So what you're deciding here is the father the domain or is the father the range? Are the children the domain? Are the children the range? Which way do I have to make this so this stays a function? So I'll give you a few minutes to think about it. Don't worry if you can't get it. These are just thinking problems. So if you think about this one, we have the set of rectangles. Oops, it was 3 and 5, I think I had here. So we have this rectangle. It has an area of 15. And we had like this rectangle and we said, well, it has an area of 14. Rectangles will only have one area. You do not get a rectangle and get two areas. Because each rectangle has only one area, these are functions. All right, so if you think about this one, so the domain of famous singers corresponds as a song that the singer has recorded, and it's a set of titles. So we'll just pick somebody everybody knows about. Elvis. Elvis has recorded many songs. We have Heartbreak Motel. Elvis also did Blue Suede Shoes. Okay, I can spell suede. But Elvis is what we can keep going with this. You know, there's Viva Las Vegas. There's a bunch of songs you can add here. But the point is Elvis has not just sang one song. Elvis is saying multiple songs. And any singer is like this. Any singer will have sung multiple songs, not just one. So because of the multiple, a singer corresponds to multiple songs. This is not a function. All right, this was a little tricky one because this one you tend to want to say that fathers correspond to children. I mean, do you tend to want to go as fathers correspond to children? The question is, does that make it a function? So let's say we have Steve. Steve's going to be the father. This is going to be the kids. Correspondence is going to be the father has kids. So these are his kids. So Steve could have Alice, but Steve is just not stuck to just Alice. Steve could also have Tim. So we're talking about biological fathers. We'll just say that your biological father. So we don't have to worry about stepfathers or anything like that. So Steve biologically could have had Alice, could have had Tim. This direction is not a function. So let's try to flip this around. Let's say we have Alice. So we're going to have the kid here. So we're doing a correspondence to kid to father. How many biological fathers can Alice have? Well, unfortunately, she can only have one at this point in time, and it's just Steve. Maybe in the future this will change. Let's say we have Bob. How many fathers can Bob have? Bob can only have one father. So like I said, if you're trying to figure out how this relationship would work so we can make it into a function, well, then the function would have to be the domain is kids, the range is the fathers. The correspondence is between kids to a father. Like I said, to a biological father. If we do it this way, now we have a function.